All right, so today we are going to talk about what it means to find the zeros of a function. I'm just reading from page 522, which hopefully you have your books open to. We have learned so far in this chapter to determine the vertex of a parabola and whether it is a minimum or a maximum point. It is also helpful to know where a graph crosses the x and y axes. Because in and of itself, the y-intercept always has an x value of 0, we can find the y-intercept of any graph by letting x equal 0 and solve for y is equal to f of 0. So example number 1, this should look pretty familiar to you based on stuff that we've already learned this year. It says find the y-intercept of each function algebraically. So g of x is equal to 2x squared minus 3x plus 5. How do we find the y-intercept? Well, we set x equal to 0. So relatively simple. 2 times 0 squared minus 3 times 0 plus 5. That's obviously going to be 5. So what that tells us is when x is 0, y is 5. There's our y-intercept, okay? B, h of x is equal to x minus 1 squared plus 2, set x equal to 0. 0 minus 1 squared plus 2, that gives us 1, or negative 1 squared, which is 1, plus 2, so that is 3, which means the y-intercept of this one is 0, 3, okay? So a 0, or another way we call it, is called a root of a function, is a value of x at which the graph of the function crosses the x-axis. It is the x-coordinate of an x-intercept of the graph. So example number 2 says find the zeros of each function, algebraically. So we have r of x is equal to x squared minus 4x minus 5. So we are going to set that equal to 0 to find our x values, okay? And this is what we have been working on in this chapter. So we set it equal to 0, x squared minus 4x minus 5 equals 0. Factor this one, gives us x minus 5, and x plus 1 is equal to 0, okay? So we set each of these equal to 0. So either x minus 5 equals 0 or x plus 1 is equal to 0, which means x is equal to 5 or x is equal to negative 1. So our solution set for this one, x is either 5 or negative 1. Those are the zeros of this function. All right, so moving on to part B, we're going to go ahead and set this function equal to 0 to find the zeros of our function. Negative x squared plus 4x minus 4 is equal to 0. We're going to factor this out, or factor out negative 1 first, leaving us with x squared minus 4x plus 4 is equal to 0. That gives us negative 1 times x minus 2 times x minus 2 is equal to 0. So x is equal to 2. Okay, that is the 0 of this function. Only one for this function. The zeros of the functions in example number 2 are easily confirmed by their graphs below. The single root in the second parabola, we only have one, that's 2 right there, okay? We only have one value. The single root in the second parabola is often called a double root since 2 factors produce the same root. You'll notice that here. In this case, the parabola's vertex is located at that x-intercept. Example number 3, find the zeros of the function to the nearest hundredth. Okay, find it to the nearest hundredth. P of x is equal to x minus 1 squared minus 6. So step number 1, we're going to set this equal to 0. Okay, add 6 to both sides. Okay, that take the square root of both sides. That gives us x minus 1 is equal to plus or minus the square root of 6. And then now we're going to add 1 to both sides, which gives us x is equal to 1 plus or minus the square root of 6. Plug that into your calculator, 1 plus the square root of 6 and 1 minus the square root of 6. Round to the nearest hundredth, and x is approximately 3.45 and negative 1.45. Okay, part B, q of x is equal to x squared minus x plus 4. Set that equal to 0. In this case, we're going to use the quadratic formula to solve this one because it doesn't factor easily. X is equal to negative 1, negative b, plus or minus square root of negative b squared minus 4ac, so 4 times 1 times 4 all over 2a, so 2 times 1. That gives us x is equal to 1 plus or minus the square root of negative 15 over 2. That is impossible, okay, because our discriminant is negative, so there are no real zeros to this function. The graph of p of x is equal to x minus 1 squared minus 6 can be used to approximate its roots at negative 1.5 and 3.5. But an algebraic solution is needed to get exact values. The fact that the graph of q of x is equal to x squared minus x plus 4 does not cross the x-axis illustrates why there are no real solutions when the discriminant, remember discriminant is d, capital D, big D, is equal to b squared minus 4ac is negative. Okay, so when the discriminant is negative, there are no real solutions, which is something that we learned earlier in this chapter. Example number 4, given the quadratic function f of x is equal to 3x squared plus 8x minus 3, find its y-intercept, the zeros, and the vertex, and then graph the function. So the first thing we're going to do is we're going to find the y-intercept. How do we find the y-intercept? We do f of 0. So f of 0 is equal to 3 times 0 squared plus 8 times 0, minus 3. So that gives us negative 3, which means our y-intercept is at 0, negative 3. Okay, so now we found our y-intercept. How do we find the zeros of the function? We set the function equal to 0. So 3x squared plus 8x minus 3 is equal to 0. Set that equal to 0. Factor this one out. 3x minus 1 times x plus 3 is equal to 0. Okay, set each of these statements within the parentheses equal to 0. So 3x minus 1 equals 0, or x plus 3 equals 0. 3x is equal to 1. X is equal to 1/3, or x is equal to negative 3. So our zeros are x is equal to 1/3 and negative 3. Now, find the vertex. How do we find the vertex? Well, we find HK. So, vertex, H is equal to, remember our formula from 2 sections ago, negative b over 2a. In this case, a is 3, b is 8, and c is negative 3. So h is equal to negative 8 over 2 times a, so 2 times 3. So that's negative 8 over 6, which gives us negative 4/3, or negative 1 and 1/3. And then to solve for k, we're going to do k is equal to f of h. So plug in either negative 4/3 or negative 1 1/3. I prefer to use improper fractions, so I'm going to plug in negative 4/3 back into my original function. So 3 times negative 4/3 squared plus 8 times negative 4/3 minus 3. So that gives me 3 times 16/9 plus negative 32/3 minus 3. And that ends up giving us negative 25/3, negative 8 1/3. So HK, our vertex, is right here. And then we're going to go ahead and graph, okay? Vertex negative 1 1/3, negative 8 1/3. So here's negative 1 1 1/3, all the way 1, 2, 3, 7, 8. So here's our vertex about right here. And our zeros are where our graph crosses the x-intercept. So that is at 0, negative 3. And sorry, trying to find the other one. And 0, 1/3. So now I can go ahead and plot there. I'm drawing my parabola right there. And you're done.